All right, pre-calculus students, we are moving on to Chapter 7, Part 2. If you remember correctly, Chapter 7, Part 2 was all of those goofy trig identities. All right, well, I shouldn't say all. There were the goofy trig identities, and then also the solving trig equations. All right, so there was a lot to this chapter, and this chapter definitely was not one of our stronger ones. So if you're trying to focus and figure out what you need to study more on, this might be one of those chapters. All right, so hopefully you have your old packets because we need to remember all of the old trig identities. I will give you a little note card so that you can rewrite them all and use them to study. No, you do not get them on the final. All right, you do not get notes or note card on the final. Okay, so when I take a look at this, this is one of those where it actually is already, like we already performed one of the sum or difference formulas, okay? I know that because I see two different angles, and then I see cosines and I see sines, all right? So what we need to recognize here is that because it's cosine, cosine, well, this was one of the cosine formulas. All right, so now I know I have to make a big set of parentheses, and hopefully you guys recognize, well, one of my angles that they give me is 80, the other is 20, so I'm going to put those in. And the big question mark here is what sign goes between them? For that, you take a look at this sign. There was only one of them, only one of sine, cosine, and tangent, I guess really sine or cosine, where the sign switched. And maybe I shouldn't use the word switched. Changed. I'm going to use the word changed, okay? And it was the cosine that changed, all right? Sine stayed, cosine changed. And so if I see a plus here, then I know that I have to put a minus here. All right. So now I can keep going. Well, cosine 80 minus 20, that's just 60. And I know that the cosine of 60 degrees is, you can draw it if you have to. 60's up here. Oh, 1/2. All right. So the answer to this problem, or expression I should say, is 1/2. Okay. So again, this is one where you work backwards. You know the formulas. This is basically the right side of the formula, and you're working back to the left side. All right. Now we're gonna kind of do a forwards one. All right. So I know that I see sine. I know that this angle is not on the unit circle. All right. I do not know where 5 pi over 12 is on the unit circle, but I do know. Let's see, let's make a list. I know pi over 6, I know pi over 4, I know pi over 3, I know pi over 2. I think I'm probably good. Let's take a look. The idea here is that you need to use angles that you know, like these ones, to get to this angle that we don't know. Now, this one has a denominator of 12. These are all different. What we're going to do is we're going to get a common denominator. So if I want to write this with a denominator of 12, that's really 2 pi over 12. And pi over 4 is 3 pi over 12. And oh my gosh, I can actually stop right now, because what's 2 pi over 12 plus 3 pi over 12? 5 pi over 12. So I know that what I'm really doing here is I'm going to do the sine of 2 pi over 12 plus 3 pi over 12. And I'm going to go a step further, and I'm going to say, well, that's actually the sine of pi over 6 plus pi over 4. All right, so now I have the two angles. I know that one of the angles I'm going to use is pi over 6, the other is pi over 4. What we really need to do now is we need to remember the sum formula. Sum for sine is sine, cosine, and then you're going to add, right, the sine stays, and we're going to have cosine sine. All right, now remember, pi over 6 was angle 1, pi over 4 was angle 2, or A and B, and so now it's again A and b. Sine, cosine, cosine, sine. And remember, the sign stays. The sign stays. So now I need the sine of pi over 6. Well, pi over 6, if you need to make a little sketch, that's fine. Pi over 6 is right here. Oh, so the sine is just 1/2, right? I'm going up less than I'm going out. So I know that this is a 1/2. Cosine pi over 4 is nice and easy. That's just root 2 over 2. Any of the pi over 4 stuffs are nice. We like those. Cosine pi over 6 is a little different, right? That's longer now, so that's my root 3 over 2. And then again, pi over 4s are nice, so root 2 over 2. So when I go and I clean this up, I have a square root 2 over 4, and I have a root 6 over 4, and the last thing I can do is I can kind of put them into one fraction. Please, 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 please remember, you cannot just add the 2 and the 6. It doesn't work like that. If they were multiplied, absolutely. We did that, right? We did 3 times 2 is 6. But when you're adding, they have to be like terms, right? Like I'd have to have a root 2 plus another root 2 in order to combine them into one. All right? Okay. So that was sum and difference. Here we go into some halves, some half angles. All right, probably our least favorite, just because the formulas are a little ugly and there's just kind of a lot of thinking that goes into them. The first thing we need to remember, though, is that if I'm looking for this angle, 112.5, that's my half angle that I'm searching for, which means I need my full angle, right? This is x over 2. And so I know that to get x, I'm going to multiply by 2. So that's going to end up being 225. Now I know that my full angle is 225, half angle 112.5. All right? Now, a couple of things. We know that the half angle, 112.5, well, that's somewhere right here in quadrant 2. So we know that that would be a negative positive. That's important. It's not a bad idea to sketch 225 just so we know what we're working with, okay? This ends up being, well, we'll get there in a second. All right? So now I know that the angle in question, the angle I'm trying to find is in quadrant 2. So this is where we need to remember our half angle formulas, okay? It's always cosine x over 2 equals, there's a plus or minus, and then for cosine, it's 1 plus cosine of the full angle all over 2. Hopefully this is ringing a bell, right? A half angle, we need to use the full angle in our formula. All right, so when we plug in 225 in both places, well, that's how this turns into 112.5, which is what we're looking for. We can only use one of these, right? Hopefully you guys recognize that because we're looking for cosine, well, I know I want the x value, and the x value we said in quadrant 2 is going to be negative, so I know I need the negative option here. All right? And now it kind of keeps going. I have 1 plus cosine of 225. You can write it. I think I'm going to skip this step, though, because I know that the cosine of 225, well, down here in quadrant 3, I should have a negative root 2 over 2. All right, negative root 2 over 2, and that's still all over 2. I hope this is coming back, because we did a lot of these. Because remember, we changed this 1, into a 2 over 2. And we can rewrite a little bit. We have negative, okay, so I had 2 plus negative root 2. So I have 2 minus root 2 all over 2, still all over 2. Sorry about that, guys. Hopefully that looks a little familiar. If you remember correctly, I don't like these complex fractions, so instead of dividing by this 2, I'm going to multiply by 1/2, which is going to help me rewrite this as negative 2 minus root 2 all over 4. So we're getting there. We're almost done. Last thing, please just remember, 4 is a perfect square, right? We can take that out. So I'm going to say that this is negative square root 2 minus root 2 all divided by 2. All right. Now I do hope you remember there was a practice test that we took a while ago, and just be on the lookout. Sometimes the answers, like some of the questions that are on the final are just kind of generated from a computer, and a lot of the times they'll do something like this. And I want you to know that these are the exact same thing. All right, let me move that over so you can see. All right, I just want you to understand these two things are exactly the same. All I'm doing is, instead of dividing this piece by 2, I'm multiplying by 1/2 instead. All right, these two concepts are exactly the same. So you have to be able to recognize that if the question, or excuse me, if the answer options are like this, well, then you need to give an answer like that. Okay? So please be ready for that. All right, here we go. We have some more half-angle stuff. This, I would say, is a little bit more abstract. And I say it's abstract just because I don't know exactly what my angle is. All right, so we're going to have to kind of figure this out. Now, we have some nice hints. I know, excuse me, oh my gosh. I know that my angle is going to be in quadrant 4, right? 3 pi over 2 to 2 pi. We know is somewhere down here in quadrant 4. It does not have to be a perfect sketch, so just draw it somewhere in quadrant 4. Remember it's a right angle, and know that we already have the cosine. So that means we have the x, or the adjacent, and we have the r, or we have the hypotenuse. Because now we can use some Pythagorean theorem to get my other side. I'm going to say that 2 squared plus y squared equals 3 squared, or 4 plus y squared equals 9, or y squared equals 5. So y equals, and this, again, what I need you to understand for sure is that it's the square root of 5. But please remember that it could be positive or negative, and in this case, what's it going to be? It's got to be the negative. Why? WHY? Because it's going down. So we have a negative root 5. So please do not forget to put that. That could definitely change an option. That could definitely be one of those kind of answers that we give you to try to trip you up a little bit. All right? Okay, but now this is great. I now know this is my full angle, right? Theta is just theta. My full angle is in quadrant 4, which ends up meaning that my half angle is going to be in quadrant 2. And again, think about this with me. 270 to 360. If I have both 270 and 360, I know that this angle, my half angle, when I take half of anything in quadrant 4, it's going to have to be between 135 and 180, and that's quadrant 2. So now we know for sure that I should be negative positive. All right. Now, I want the tangent of theta over 2, or my half angle formula. There were 3 options for tangent, and if you remember correctly, one of them is way nicer than the other, nicer than the others. The one that we really like to use, oh, my bad guys, tan theta over 2, we really like 1 minus cosine over sine. I like this one a lot because it has one single term in the denominator. That means there's going to be way less work and reducing and trying to, simplify, I guess. I don't know. That's not really the word I was looking for, but hopefully you understand. I like one term in the denominator. It's going to make it a little easier at the end. Okay, so let's see here. I know that my cosine of theta, either from the original or from your picture, is 2 over 3. I also know that sine is negative root 5 over 3. Negative root 5 over 3. All right, now very similar to the last one, remember that we need common denominators to add or subtract fractions. So I'm going to go ahead and say that this 3 minus 2 is, so it's 1 over 3 over negative root 5 over 3. All right. Now this is actually even nicer. What can we do when we have the same denominators? Goodbye. 1 over root 5, and I'd make it negative. All right. Now, some of you guys during the year always rationalized your denominator, and that's fine. I just want you to understand there could be times on the final where an option has a rationalized denominator. So just remember that if you need, like if your answer options have rationalized denominators, like if you don't see this, well, just remember that these two things are absolutely equivalent. How did I get it? I multiplied top and bottom by root 5. Okay, so be on the lookout for these two types of answers on your final exam. All right, two more. No more identities, at least for right now. But we have some equations. I shouldn't say no more identities, but moving on to some equations, okay? That's what I'm trying to say. Okay, so we are going to solve from 0 to 2 pi. That means that we need to find absolutely every single angle between 0 and 2 pi that satisfies this equation. Now, things to be on the lookout for solving. You need to have consistent angles and consistent trig functions. This one I'm okay with because there's only one angle that I see and there's only one trig function that I see. I just see sine. So I'm not too worried about this one. I'm just going to start to solve this one as normal. So I would move the 1 over. Sine squared 3 theta equals 1. Well, if I want to solve for theta, I'd have to square root both sides. So now I have sine of 3 theta equals plus or minus 1. Now, if you remember, and I cannot stress this enough, this is the angle. You never change the angle. You can't. You can't do it. Okay? Do not change the angle. What we do here, now that we have a single trig function equal to plus or minus 1, we want to sketch where those solutions are. All right? Where is sine plus or minus 1? Well, that's either straight up or straight down. So pi over 2, 3 pi over 2. This, if you remember correctly, is where the 3 theta comes into play. Normally, I would say theta equals blah, 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 plus or minus blah, blah, blah. I'm not using theta, though. What is my angle? My angle is 3 theta. And now I know that 3 theta has to equal, well, how many equations do I need to write for this one? If I go from pi over 2 to 3 pi over 2 and then back up to this, what am I doing every time? Oh, there's a nice rule for that. I don't need to write multiple equations. I can just write one equation. I can say pi over 2, and then my rule is adding a single pi. All right? Now, if this had just been theta, you'd be off the hook, it'd be done, but it's not. Right, it's 3. So what we need to do is we need to divide or multiply every single thing by 1/3. Okay, I do that because I need theta. I need to know my thetas, not 3 thetas. So if I do 1/3, yep, theta, and then 1/3 of pi over 2 is actually pi over 6, and then this would be 1/3. Okay, so pi over 3n. Alright, what did I do? I literally just multiplied every single thing by 1/3. Or you can divide by 3. It's up to you. I think I used to use divide by 3, and then enough people complained that I think I started going this route. Alright? Complain. Alright, so now I need to make a list. Now I know that I need to get every single angle between 0 and 2 pi that satisfies this. So, let's do it. Well, I know for sure I'm starting at pi over 6. That's great. How am I going to add pi over 3 to pi over 6? I'm not going to think about it as pi over 3. I'm going to think about this as 2 pi over 6. So I have common denominators, and I can just add over and over and over again. Because now I know I need to do pi over 6 plus 2 pi over 6. Well, that's 3 pi over 6. Plus another 2 pi over 6. Plus another 2 pi over 6. Plus another, plus another, plus another? No, I can't, right? If you remember, 2 pi is the same thing as 12 pi over 6. So I can't go above 12 pi over 6, so I am done here. Now, the last thing, and I'm sorry I didn't do it right away, but please make sure that when you're looking at your test and you're looking for options, that everything is reduced fully, right? Like 3 pi over 6 is the same thing as pi over 2, and 9 pi over 6 is 3 pi over 2. So you would be looking for a list that has 1, 2, 3, 4, 5, 6 answers to solve this problem. Okay, here we go. Last one. We're getting there. We're close. Now we're in general, okay? So this is going to be a little less work. We're not going to have to make a list. We're just going to need our general equations. But let's see here. Problem. Let's start with the good news first. I see just theta and theta. Okay, so that's nice. I don't see multiple angles. That's really, really good. The problem is that I do see a sine and I do see a cosine. Can't do it, right? We cannot do this. We need to get everything into one of those trig functions, and hopefully you guys remember there's not anything I can do with just a cosine theta. There's no identities for that. I don't know anything. But, at least, my bad, there's no identities for cosine theta turning into sine theta. But there are identities for sine squared and cosine squared, okay? So, I know that I can change this sine squared. And that's going to break open this problem, all right? We need to remember that sine squared is 1 minus cosine squared, right? That's just the Pythagorean identity. Sine squared plus cosine squared equals 1. I manipulate it, I get 1 minus cosine squared. All right? So now, 1 minus, got to distribute, we have a negative 2, we have a positive 2 cosine squared theta. We still have minus cosine theta. All right, this is doable. I'm going to rearrange it. I'm going to say 2 cosine squared theta minus cosine theta, and then I have a 1 minus a 2, so negative 1. All right, hopefully you guys remember some of this stuff. Now, we need to factor this, right? We have a cosine squared and a cosine. That's just like a quadratic, right? Again, you can treat it as x squared and x if you see things better. I'm going to try and do it normally. So I know that I have to have a 2 cosine and a cosine, because those two have to multiply to that. Now I need to add to cosine theta, and I need to multiply to 1. So I definitely know that they're both going to be 1s, which is good. But which one has to be negative, right? One of them has to be negative. And hopefully you agree with me that because this is a negative cosine, well then my negative has to go with the bigger of my outers and inners, right? I need to multiply this 2 cosine by negative and this single cosine by positive. All right. Now we can use my favorite property, zero product property equals 0, cosine theta equals 1. What's that? Cosine theta equals negative 1/2. And we're good there. And now it's unit circle time. All right, unit circle. We want to plot all of this, right? So if my cosine has to be negative 1/2, then I know I'm going to be at this angle here of 2 pi over 3. I'm also going to be down here at 4 pi over 3. That's awesome. What about cosine theta equals 1? Well, that's just straight out to the right, and that's at 0. This is actually pretty awesome, guys. How many equations do we need to write for this? We only need one equation, right? There is one nice single equation we can write, and why is that? Because there is a nice rule to get from here to here to here to here to here, and on and on and on and on, okay? So we go and we say theta equals, you pick your starting point, 0, and you figure out your rule. Well, how do you get from 0 to 2 pi over 3? You add 2 pi over 3n. And again, you could keep adding 2 pi over 3's to get around that circle. Okay? So, again, this was a tougher chapter for us. I hope that you guys are picking some of this back up. And please study. Have a good one. Peace.